My name is Jason Kwalchik, and I am presenting the research I conducted with Dr. Nadav Goldschmied entitled Gender Participation and Performance Trends in the NCAA Rifle Championships. Is the Gap Closing? Title IX, enacted on June 23, 1972, prohibits the exclusion of individuals from education programs based on their sex. Since its enactment, there has been an increase in the number of women's sports teams in both high school and collegiate levels. At the high school level, research has shown an increase in female participation in sports over the years, but male participation is still higher, and males remain the majority of athletes. Research has also been conducted on sports unrelated to Title IX, like the Olympics. As this graph shows, female participation in the Olympics has increased over the years. However, males were still the majority of athletes in 2004 when only 40% of the competitors were female. In regard to our study, we investigated gender participation and performance in NCAA rifle shooting. Unfortunately, there is not much research in this area. Therefore, we first explored research in regard to general gender differences in sports. For example, we explored differences between male and female runners. Tatum et al. Used the times obtained by the Olympic champions in the 100-meter sprint for men and women to create two linear regression lines, with the blue line for men and the red line for women. As the graph shows, male runners have faster times than female runners. The lines, however, are not parallel, which mean that the gender differences are narrowing. Using the lines they created, the researchers extended the lines out until they intersected, which is the point at which no gender difference exists. As shown by the green arrow, it was predicted that male and female runners would perform at the same level in the 2150s. Other research has shown that this is not the case. Seiler et al. Compared the times of running finalists in the World Championships and the Olympics from 1952 to 2006. They computed the percent difference between the male and female runners at the 100-meter sprint, in which positive percentages mean males are outperforming females. As the graph shows, the gender difference decreased until the 1980s. Since the 1990s, the difference between male and female runners has grown. The researchers suggested that this upward trend was due to stricter drug testing policies, and the difference now reflects the biological differences between males and females. There are a number of differences between males and females that could affect their performance in sports, a few of which I listed in this slide. For example, males tend to have more muscle mass and higher anaerobic and aerobic capacity than females, which helps males outperform females in running, a sport that requires much physical exertion. For sports that do not require as much physical exertion, however, physiological differences should have less effect on performance. One such sport would be rifle shooting. Of the few studies on gender differences in rifle shooting, one study involved male and female military personnel shooting at a target using a laser simulator, and each participant was given a score based on the accuracy of their shots. The results showed no gender difference. There's another study, however, that found a gender difference. In this study, the participating college students were enrolled in a riflery class, did not have previous experience shooting from a kneeling position. Across 5 sets of trials held over 3 weeks, the shooters were asked to take shots at a target from a kneeling position. The results showed that male shooters were only significantly better during the first and third trial, which suggests that the gender difference in performance disappears with experience. In regard to our study, we analyzed the gender composition and performance of more experienced NCAA shooters. In particular, we analyzed the NCAA Rifle Championship. The NCAA Rifle Championship is an annual co-ed competition that contains 2 tournaments, the team tournament and the individual tournament. In the team tournament, the top 8 teams compete against each other. There are 5 shooters on each team, and each shooter must shoot using both a small bore rifle and an air rifle. Small bore rifles use gunpowder to propel the projectile, while air rifles use gas or air. Furthermore, small bore rifles can be heavier than air rifles. For the small bore event, shooters take 20 standing, 20 kneeling, and 20 prone shots at a target 50 feet away. For the air rifle event, shooters take 60 standing shots at a target 10 meters, or about 32.8 feet away. The team score is the sum of the 4 best scores in the small bore event and the 4 best in the air rifle event. The teams are ranked based on this score. Following, the individual tournament is held, in which the 8 shooters with the highest scores in each rifle from the team tournament compete against each other. Each shooter now takes 10 standing shots. The obtained score is added to the score they received prior to the individual tournament. The shooters in the individual tournament are thus ranked based on their combined score. Using archival data, our study was conducted to investigate gender differences in team composition and performance in the NCAA Rifle Championships from the 2007 to 2011 seasons. Since past research has shown that female participation has been on the rise, it was hypothesized that female participation increased. In regard to performance, rifle shooting does not require much physical exertion, so physiological differences between male and female shooters should not have an effect on performance. Therefore, it was hypothesized that there would be no gender difference in performance. For this archival study, data was collected using the online database from NCAA.org. The database provides the scores the shooters obtained in each part of the championships, along with the order of finish amongst the shooters. Furthermore, we supplemented this data with information from the competing schools pertaining to the gender of the shooters. We utilized a generalized estimating equation to account for the correlation between multiple observations in the dataset. This statistical procedure was introduced as a method of analyzing correlated data that otherwise could be modeled with a generalized linear model. We had 24 unique athletes in our sample, of which 21 participated in 2 annual competitions and 3 participated in 3 annual competitions. We used IBM SPSS version 19 to conduct the analysis. We utilized rifle type, the year, and 1 performance measure in 3 competing models to avoid multicollinearity. The outcome variable was gender. The results of the first model, which used the order of finish as the performance measure, are shown here in the table and graph. The order of finish was not significant. In addition, the rifle type was not significant not only for this model, but for the other 2 as well. Furthermore, the year was significant across all 3 models. As shown in this graph, males made up the majority of shooters in 2007. However, the number of female shooters increased with each year. Female shooters became the majority in 2010, and then there was equal representation for male and female shooters in 2011. The second model, the results of which are shown on the graph on the left, used the total score for the performance measure. The total score was not significant. The third model, the results of which are shown on the graph on the right, used the score on the last individual round for the performance measure. This score was not significant either. Consistent with our first hypothesis, female participation increased from the 2007 to 2011 seasons. In the 2007 season, males were the majority of competing shooters. However, there was a shift between the 2007 to 2011 seasons such that female and male participation became equal. Consistent with what was further hypothesized, the order of finish and the scores were not significantly different between male and female shooters. To put it another way, they performed equally as well. This suggests that the physiological differences between males and females does not have an effect on shooting performance. There are a few limitations to this study, however. First, the time period that we investigated was only 5 years, which is fairly short. Title IX was enacted in 1972, and the NCAA rifle program began in 1980. The results cannot explain this recent shift in participation or participation rates prior to 2007. Second, only the shooters in the individual tournament were used, so the results do not generalize to those shooters who did not qualify. Third, a number of the teams are women only and not co-ed, which makes interpreting the results more difficult. For example, it might not have been the males made up of the majority of shooters from 2007 to 2009, but instead there was an underrepresentation of female shooters in the individual tournament during that time. A strength of the study was the use of performance during competition. Prior research only analyzed performance during experimentation, which might not generalize to performance during competition. Due to the lack of research in this area, future research is still needed on the gender participation and performance of rifle shooters. Since one of the limitations was the short time frame, one idea for future research would be to analyze a larger time frame if the data is available. Our study also does not explain why the observed shift occurred, so another idea would be to survey shooters about their opinions of the sport in regard to gender participation and performance. One of the implications of the study is that sports that require less physical exertion might show similar trends, such that there are no gender differences in performance. The second implication of the study is that there might not be a performance barrier for male and female shooters in the NCAA that prevents them from participating. Finally, we did not find a difference in performance using the limited data we collected. Based on this limited data, however, the implication for Olympic shooting events, which currently have males and females competing separately, is that the events should become mixed gendered. If you have any questions, please feel free to email Dr. Nadav Goldschmied at the provided email address. Otherwise, thank you for watching.